a John Deere 650K. This one is reported of having some body sensor issues. That's the blade sensor. I just like to go through and take a look at everything, because if I can spot something that I can fix for them right away. Oh, that's interesting. It looked like it got kind of squished in there a little bit. Oh yeah, see, not getting voltage. Well, it is getting voltage, but it's not the right kind. So obviously it's not working. Doesn't look like they had hit it, but that looks interesting there. That might have damaged the cable inside. We'll see what we can do. Oh, good. They left their machine on. Interesting. We can go in here, check the values, see if there's any values, and do a factory reset and see if that doesn't clear it up, if it's just an issue with the sensor like that. So I'm not sure if they have their base on out here. Doesn't look like it. Nothing, 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 nothing. Okay. Well, let's just do a factory reset on it. Go into true. Factory reset the main. Factory reset the auxiliary. Just check, see how much they have in their system. A lot of times that bogs things down and causes issues, but this clearly is a bad body sensor, cable, or Y cable. It's only really, well, 4 components. Where is their control box? Sometimes it's mounted down here, sometimes it's mounted here. Now we got cables running in. That is for the seat. The modem cables have to go to something. Yeah. No base. IMU not oriented correctly is the fault. Okay. Well, we'll pull the floor up. We'll test the voltage out to the sensors, make sure the voltage is good, and we'll test the cable, test the Y cable, and then we'll test the sensor. This is a C-frame IMU. We call it the third IMU. So we're flashing green on this one, so that one's working properly at least. Look at that little tiny blade on that thing. That is tiny. Wow. I don't think I've seen one that stubby. Let's see what we get in here. Yep. And we're flashing green on that one too. So I assume if we don't have damage there, then it's a sensor. If it's a cable, I suspect that's probably where the damage is going to be. It might have caught something on the track and it pushed it up in there and kind of squashed it, so we'll see. So first things first, remove the cover, and then just the first green clamp you're gonna have to knock loose just enough to get the cable out. So the first green clamp needs to come off. I like to take a little wiggle right here just to see if anything is damaged before I pull it apart, but I don't feel anything weird. Clean off as much dirt as you can. You don't want all that dirt, especially sometimes, most of the time it's muddy. You don't want all that dirt getting into the pins and stuff. So if this does end up being a body sensor, which it's most likely definitely looking like, we will have to calibrate. And as far as calibration is concerned, yes, you can do just the body calibration, but it's better to do an entire calibration, blade and body, because everything runs off of this body sensor, its roll values. So I mean, if you change one component, just recalibrate everything. It just makes life so much easier, eliminates all the other problems you may find. You see that turn green? Interesting. We may have a bad cable. Huh. It's probably going to be right there in that spot. That's interesting. Well, I'm going to have to pull the floor up, so I'm going to clean this up first. Let me throw a sensor on it and just see what it does. If it turns red, then we know we have a bad cable somewhere. So let's swap that sensor out real quick. Good time to inspect the pins on both ends. And look for burns, melts, bends, breaks. I don't see anything going on with that one yet, so I still think it's a problem right there on the cable, which is going to be interesting because I don't have a cable. Alright, let's throw a new one on there and try it. Well, interestingly enough, just the sensor alone caused a nice green light to pop on, so maybe we don't have damage up here, but it's always a good idea just to give it a little wiggle and pull and push and see if anything weird is going to happen. Nope. Maybe just a sensor. Interesting. Well, alright, so we need to go through and calibrate this thing, and the first thing we need to do for that is get us on a flat spot. This isn't quite flat. That looks a little wet. I'll track up on that. It's a little bit higher ground. That looks flat enough to do a nice calibration, so we'll get it up there. What we're going to need for calibration, you need a 4-foot level, 2-foot level, square, paper, pen, and a tape measure. Now, you can do this in feet and inches, but it's better to do this in tenths. More precise. So, alright, let's move the machine up to the flat spot there. So what you'll have to do, once you've changed the sensor, just restart it, power down, restart, and then you should see your values return, which we have. Our sensors are connecting, and we don't have a base out here, it looks like. Let's see if there's any distance to base. Yeah, see how far away that is? What are they using? Hold on, let's find out. Are they on network? No, so they got Topcon Digital 2 UHF, so no base. They're tracking 14 out of 20 satellites, but distance to base is like a zillion miles away. So, yeah. We're going to have that base on in order to do a full calibration and check this thing. So, yeah. But for now, we are initialized here. so we can go ahead and calibrate at least and get the machine in. But in order to check it, we need to link up to the base for the project to make sure it's matching. Alright, let's move this thing. Okay, so first things first, I hope I didn't mess that up too much. They can fix it. First thing first, we got to get the blade square with the machine. So, need our tape measure, need our tools. Okay, blade is square to the machine, and you can do that simply with tape measure on the cylinder. Both cylinders kind of square it up. You can measure back to the track. You can measure back to the grill. You can measure back to the front pin right there for the idler, sprocket, whatever you want to call that one. Yeah, so get it square to the machine as best you can, as close as you can, and start taking measurements. So what we'll take first is the width of the blade, the full width of the blade, and we'll come over, measure from the right corner. Everything is measured out the right corner over to that first bolt, and then that bolt over to that bolt, and then we'll do our blade cutting edge lower up to the center of that bolt, and then level, and then measure over. We got to measure from the right corner over to our sensor down, from the sensor crosshair over to the cutting edge. So just a few measurements on the front, and then what we'll do is we'll measure back from the right corner over to the pin, over to the antenna, over to the body sensor, and we'll measure from this pin to that pin. We'll get the width, the length actually, from sprocket to wheel, and then we'll get the width of the tracks, and then we'll go up on top and we'll measure from main antenna to auxiliary antenna, and any offsets up there. Oh yeah, it's got a third IMU, so we'll have to measure the third IMU from right corner of the blade. How far back is it? How far over is it? The height of it, and then we need center of rotation. How far back from the right corner of the blade is that center of rotation? How far inside it is from that corner? And then we need the pivot point here. We need height from ground level up to the pin, and we need to measure over to the right corner. How far back is it, and how far on the inside of it from that right corner. So, a few measurements. Measuring the blade and the sensor, it's all pretty much self-explanatory. Coming over here, what I like to do is I like to come off that pin. I use a straight level, basically, bring it out here, just put a mark, drop it down, level, mark. Same thing with the body sensor, bring it out, coming off that arrow reference point, make a mark, drop it down, make a mark, and the antenna, come out, bring it down, make a mark, level it down, make a mark. That way, all you need to do, set your level on it, like so, square it up to the tracks, run your tape measure to your square. And I just set my tape measure right down in there, and that gets me that measurement to each of those points, like so. Now, all we need to do is square this level up to the machine and that mark. Looks like it's going to be 6, 4, 8 for the pivot, and we just jot it down. So right here, 6.48. Move over to the next. This one's going to be the GPS antenna. Wow, they got that right on the 5, so 7.50. For how far back the main antenna is from the right blade tip. Now the body sensor. Squared up. Looks like we're going to be 7. Looks like it's going to be 808. 8.08 for the body sensor. And that's right here. So 8.08. Now a lot of these numbers are going to be the same in that system because it's already been measured up. But if there's anything different, we have the information right here, so we can change it and get the measurements and calibration a little bit tighter than what it was before we found it. So, oh, yep, don't forget your pin coming out. Basically just take a level, come straight down, mark it, and then set my level over here and take the reading. Now when you're by yourself, it's kind of hard to pull a tape measure from that pin point over to that pin point. So all you need to do, take that first measurement, right? You got that number. That's the distance from the right corner blade up to that pin. Extend your tape measure out, shoot a point here, and subtract that first part. And that leaves you the second part. So I had 12.45 here and 4.65 there. Subtract the 2, and I got 7.80. That's the distance from that pin to that pin. Super easy. Alright, so the other thing we're going to have to do, because we're not using a total station, is we are done with this tape measure now. So we can take this. We need to physically measure from that antenna straight down, level, to the tip of the track right there. Be consistent on both sides. Measure to that point, and then you're going to measure straight down from that point. Get those 2 measurements on this side, get the 2 measurements on the other side. Track width, you just pull from the rear here like this, and we have 775. Now we just need to know our pivot point for the blade. It's coming down. Oh, find the center. We're at 095. And what I do is I just take my level, put it right there on that little shim. That's pretty much the center of that rotation. What I'll do is I'll drop a little something. See where it dropped? You can do this with a string line if you want. Just set that right there like that. Eyeball level it across the blade, and then carry it forward and just measure that distance right there. Keep it level going across. This one's not super critical, but it is. So we got 127. 127. Alright, good. Now we just need a couple more things here. We need to know how far down that pin is, or how far up it is from the actual ground. So you don't want to be on the track, you want to be on the ground. And it looks like we're going to be 1.11. Now we need to do the third IMU, and that's over there. So with the third IMU, what we need to know is how far from the ground up to that crosshair, how far from that crosshair to the tip of the blade, the cutting edge over here, and from the cutting edge, well, that's basically that one. The right corner cutting edge, how far over is it? So we'll determine that. So sometimes these are a little bit tough. You can line it up best you can. Look for a feature down on the blade. There's usually cuts and dents and all that stuff. And just make a mark. So that's how far that sensor comes over. Double check. That looks pretty good. And all you're going to do is carry that mark down to the bottom of the blade with your level. Carry that mark down here, mark it. Sorry. Now we just need to take a measurement from that corner over to that spot, and that's how far over this sensor is. And then we need to know from that crosshair how far over to the cutting edge. What I like to do is I just take a shot to the outer edge here, and if you level this, it's always off a little bit, and you just add that couple hundredths to it, and that's your distance from cutting edge. Alright, we got everything we need down here, so we need to go up on top of the machine and basically see how the antennas are, if they're in line, and they should be in line with the center. If they're not, how far over in relation to the right side are they? So from each other. So you got the first one and then the second one, so you need to know that information. Now the original measurements of these antennas in the system should not have changed because there's nothing up here to wear down like the cutting edge. So I just take my straight edge and make sure they're in line with each other, and they are. So, and then we just need to know, well, which one's higher? Is one higher than the other? And it looks like the auxiliary is just a little bit higher, so we'll check the system and see how high, but we can also check that with the level as well. So basically all we need to do is take a measurement from center to center, and it's usually around 5.65, which is good for a John Deere. Nice. So we got right here. So we'll do this 5.65, and I don't see any offsets. 0.0. Okay, that's everything we need. Alright, so the owner's going to go throw the base up, so that's good. We can actually get the system up and running. But anyway, so what you'll need is, you got the width of the blade, right? We got 10.29. Divide that in half. That's going to be your center of rotation. That's also going to be the center mark for your antennas running up the cab. So all we need to do is physically go into control, machine setup. We're going to change that date to today's date, edit. If we can. We'll just add the date. So what is today? Let's find out. Let's find out. September 10th. So we'll just add a space 9-10 20-21. What that will do, it changes the name of the machine file, and if we have eyesight on this, which we do, we can remote into this machine. So this is going to send the new information, all the new measurements, to our system so we can have the updated machine file. Hit OK. Make sure that all the information is correct, and yes, cab dual. We'll see if it's on, yep, it's on tape measure, so that's good. The other option is direct instrument. We didn't use a total station, we didn't use an instrument, we used tape measure, so that's good. MCR3, 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 3D MC Max, yes. So here are our measurements, and we'll just run through these and change them a little bit as we need to. So number one is how high from the right tip is that blade sensor. They got 2.08, I got 2.11. Is that enough to change it? What were the conditions when they measured it opposed to my conditions that I measured it? It's enough for me to change. Number two, how far over is it? Let's see what I get, 1.95. They got 1.98. So there's some wear on that cutting edge. And I don't know the last time this was calibrated, so number three, how far back from the right tip? And we got that right there, 1.08. They got 1.16. That's how much that cutting edge has disappeared. It's probably brand new. So it lost 800s. 5 is the center. That is the blade divided by 2 is 5.14. They got 5.17. So the blade has been worn down a little bit. Center of rotation. Number 5. How far from the cutting edge up to that center of rotation? They got 1.0. I got 0.95. Is that enough to change? It is enough to change for me. Body sensor. Number 1. And I didn't get that one. How far to the ground is it? We got 1, 2, 1, 1. 2, 1, 1. 2.11, they got 2.19. Alright, so number 2, inside. That one I didn't get either. That one's also easy to do. So it sits right on that frame right there, which is almost equal to this one, which, if you run along the C-frame here and come out, you can actually measure out to the end of the blade. That is 232, and then just measure the rest of the way out to the tip, which we're gonna need our square again. And then I just run this right off of it. And again, this one doesn't have to be perfect. So we can go from a C-frame over, down. So I'm going to say it's roughly 3, 4, 2. Let's see what they got. Three, 3, 4. Well, that's a lot less than what I got. So I'm kind of dyslexic, so let me just double check. I might have a number or two backwards. Oh, that is a 4. A 3. Actually, it's more than that, isn't it? We can go 351 or 350 and be safe on that one. Yeah, so that's off quite a bit. So I'm gonna go 350. Okay. Number 3, the distance back from the right. What'd we get? Where is it? Where are you? Did I not write that down? Okay, let me go grab that. Thought I did. Yeah, I did. There it is, right there. .08, and they got 8.08. So we know they were really good on that one, at least. Let's go next. Now this one's for the C-frame, which should be a negative, because if you, and these aren't negative, they should be negative, because if you see where the C-frame is on this image, ours is on this side. So if it shows you an image like number 2, distance from right over, that's a positive number. As you see, they got a positive number. I guess you can extend it over with a positive number. So I guess that would be right. Alright, we can do that. That's fine. So, number 1 is down. They got 1.55, they got 1.57. And number 2 would be from right corner. I got 6.13, they got 6.10. And then behind is number 3. And I got 1.82, they got 1.82. Alright, so blade pivot point. The first one would be 1.11. That's off. The second one would be the distance from the right blade, and that's 6.48, and they got 6.48. And then the third one would be 1.27 to the center of rotation, so 1.27. Not sure where they were measuring to on that one, but so number 1 is distance from pin to pin on the wheels down there, 7.80. They got 7.75. That's off by 500. My method is pretty precise. And then the next one is 4.65. They got 4.62. And next, now here's the measurements for the antenna. So number 1 is on this side, number 2 is over there. So, and this is looking at the machine, missing the blade. So number 1, I got 7.42. They got 7.34. So we'll put 7. I'm gonna put 7.41. Because the other side was 7.40 and I'm at 7.42 on this side, so just divide it in half and find the center. 2, same thing, divide it in half, find the center, the median. We'll do 2.60. 7.41. Make them the same if they're really close, which they are. And this one will make 2.60 and 2.60. And then it wants to know the track width. Track width is 7.75. They got 7.76. It might have wore down a little bit. Put the actual information that you measure at the time. Don't assume the information that's already in there is correct. So how far back is the main antenna from the cutting edge number 1? And we got 7.50, they got 7.51. The other side, both sides should be the same if the blade is square, which it is. And you see they got 10.33 for the width of the blade. We got 10.29, so we're missing some blade. That could throw you off if you keep that information in there and you don't use the actual information. That'll throw the system off. Alright, so here's the top, the antennas that we measured. Number one, what is the difference between the main and auxiliary height difference? And they got 800s, no, 8/10ths. There's no way. There's no way. There is no 8/10ths difference right there. So I'm not sure what's going on with that, but I am going to put at best 800s. Okay, because that is 8/10ths is too much. And then number two, are they in line or is one offset? They look completely straight, so 0 is good. And then number three, the distance between the two. And I got 5.65, and they got 5.65, so that information didn't change, except number one, which was very weird. That is not 8/10ths. That auxiliary is not 8/10ths higher than the main. So might have been an error to begin with. And that's it. That information is in there. So now all we need to do is get this thing started up and start running through the calibration. We'll do the MC2 Plus sensors first. Get the sensors calibrated to the machine, blade heading, blade rotation, and then body heading. So with the body heading, we're going to need a mound of dirt, because we're going to have to back up on that and create this kind of scenario with the front of the machine down so that we can level it and calibrate the body sensor, because that's the one we changed. And we can actually just tool over there and hit that pile right there. That'd be good. So that's the closest one. Alright, so let's get this machine ready to go. Just need to clean up a little bit. Now with calibration, all you need to do is follow what it says on screen. So we'll do the first one and calibrate. So this one says park the dozer on a rigid surface, blah blah blah. Match the body with the blade. That's really easy to do. Pretty much find a spot that's going to be good to set your level. It's going to give you the best option for how this machine is sitting. And that piece right there is probably going to be a lot better than that piece up there, because that's the body, the steel body, and it could be bolted crooked or anything, but this is the steel frame. So we're sitting at looks like a 0.2, a positive. We're sitting at a positive 0.3. That side of the machine is up a little bit higher. If I bring it down to 0, you'll see the gap between the level and the frame. So that side of the machine is sitting a little bit higher. So we're at a positive. This side is positive if it's up. So we need to get our blade to match. So I'm going to need a couple magnets, and I'll show you how to. Alright, so you're just going to need a couple magnets on the blade. And this one's kind of tough. So we'll set the magnet here. Put it right on the top part of that bolt. Make sure they're both the same. Really close to being the same. We don't want to go off the cutting edge, because the cutting edge could be worn. Alright, that looks good. Set your level on there. And we need to get to positive 3. Where are we at now? We are at a positive 7. Alright, so we just move the blade until that reads the body. Alright, so the blade is at a positive 0.3. Best thing to do at this point is just look at it and see if it looks right. Sometimes these blades need some shimming. This one is tilted down this way a little bit. It's not perfectly level with the body, even though the level says it should be. So could have some messed up shims, but it's close enough to work. Once you get that, once you get your blade and your body set, you're just going to enter the information. So right now it says it's sitting at a negative 0.1%. It's not. It is a 0.3 positive and set. Let it cook for a little bit. Let it recognize it. So that blade was off about 0.4%, which is quite a bit. And hit next. Here, we took these measurements, you remember? So they want to know the distance from the outside to that pin. So number one, we got 1.25, they got 1.26. We're going to use our current information. Number two, we got 7.80. That didn't change. And here's the blade geometry that we did. So number one is just measuring down from the center of the bolt to the cutting edge. That should be 0.28. That has changed. Number two, going up and measuring to an imaginary line, should be 0.22. Done. Now, we need to take a main fall reading. So we're going out on each of the tracks. We're setting our level to seeing if this machine is a negative or a positive, and we're going to get these two values on each side, divide them by 2, and take the median, the center. I'll show you. Hold on. Now sometimes if you're on uneven ground, tracks are going to be a little weird. Try to set it back as far as you can without hitting this upward area right here. And just take that reading. This is a negative. You see how the front end is falling? So this is going to be a negative value. We're at 1.6, negative 1.6 on the right. Negative 1.0 on the left. So all you need to do, 1.6 plus 1. What did I say that was? Let's remeasure it. 1.0, I think. Yeah, 1.0. Alright, so 1.6 plus 1.0 equals 2.6 divided by 2 equals 1.3. That should be negative 1.3. And see, it's not, so we're off. Now we're right. Let that cook. Once it gets there and cooks a little bit, then you can hit finish. And you can go to the next by hitting next and calibrate. Alright, this one basically blade sensor alignment, raise the blade all the way up. get the blade to 0 and enter the value. You'll have to adjust the heading. Adjust blade slope until smart level reads 0.0. Okay, blade is at 0.0, the level is on the magnets, and you see the blade slope is actually reading 0.3, 0.2, so we need to adjust that. So basically if we come down 3 on this one, we should be really close to 0. So we will do 0.1 and see where that takes us. It's coming down. Flashing. We need to go one more. Oh, there it is right there. I'm going to go 0.0. Let it cook. And that is the blade sensor's new slope. 0.0, which it should be. Next, blade rotation. Calibrate. This one's a little tricky because we've seen some issues with this one. Basically, you're going to bring it down, keep it level, just touch the ground with it, and you're going to rotate this to the right. That's the first part. Keep the hydraulics engaged, and then hit the button. And then you'll do the same thing to the left. Rotate it to the left, keep the hydraulics engaged, and hit the button. And this is always best to do on high RPMs. Keep it engaged. And do the other side. Do that again. High RPMs. Hit next. Keep it engaged. Next. Flip it around to the other side. Keep it engaged. Finish. And hit next. You can recenter your blade. Now the only thing we have left to do is the body heading. Oh, pitch compensation. Forgot about that one. Park dozer on a rigid surface, raise blade in the air and measure the cross slope. So you're just going to bring this up just a little bit, like about that much. And we're still at 0. I haven't changed that. So I'm just going to go out there and measure down. Distance from the cutting edge down. From the center, we have 0.8. Correct me on that one, it's 0.08, 8 hundredths. And hit next. And then rotate. And do the same measurement. .05. Next, rotate, take the same measurement, now, we need to do the C-frame. Get your blade squared up. We got to set our small level on the C-frame and get the main fall slope. Alright, it says to use the frame, but
I like to use the cover. I like to use the actual sensor itself. So if you put it on the sensor, we are at a negative 5.3. And this says negative 6.2. So we just need to fix that. Negative 5.3. Let it cook. That recalculates that third IMU sensor for the C-frame. Next. Now we got to get the back end of this thing up on a little slope. Get it to 0. And that's going to set the body for us. Right now it's still sitting at a 0.3. We need to go put it at a 0.0 up on a little slope. Alright, so we already know that this slope is correct because the way we sit, we've already checked the body. So if we take this over there and put that at 0.0 when we back this thing up, we should be good. Let's go do that. We're going to move this over there. And there we go. Body 0.0, perfectly level. And let's go see what it's reading. It's reading 0.2 with an offset of negative 0.6. So if we go negative 0.8, that should probably go to 0. Let's try it. Wrong way. So let's go to negative 0.4. Set. There we go. I have to go to 5. Let it cook. Yeah, I need to go a little bit more. A little bit more. We'll just try 0 and see what that does. Close. We'll go to negative 0.1. There we go, holding at 0. Next. Alright, so this one is for the C-frame mount, the sensor. So we got to get this machine cocked sideways, and we're going to take another measurement off the third IMU sensor. Alright, here all you're doing is you're tilting the blade and lowering the blade until everything matches, okay? So you could park the dozer up on a little slope, and this is level pretty much, so we're sloped down, and you just match the numbers as close as you can, and it was just there. Moving around, it's good enough for me, and just hit next. Now they want you to place that smart level on that sensor again and get a reading. And we got a reading of negative 2.7. Oh, well, let's see what it's reading. It's reading negative 3.2. So we need to make sure that reads 2.7, not negative 2.7. So let's come down 0.0 and see what that does. It's moving. It's not very fast. Alright, so we'll go negative 0.2, negative 2.8, come on, 2.7. We'll go negative 0.4. There it is, negative 2.7. That's what we want right there. Finish. Ensure it at least 10 seconds, blah, blah, blah. Let it cook. And that's good for me. Next. Exit. Okay. Calibration is complete. Now we just need to test it. They don't have a benchmark here, so we're just gonna have to, they don't have a rover either. See if this is finished surface right here. Set the blade down. That's pretty close right there. That's about finished surface right there. So you see we have a little gap right there. What I can do is I can adjust this to match that surface and get them close, because I'm betting you this is probably finished surface, but this machine, if you remember, some of the measurements were off. I'm going to trust this new calibration with new measurements over what they were using before. So you might have to add a little bit more material in here to get back to original surface. If he has an issue, because I'm not going to be able to check this because there's no benchmark, there's no rover out here. If he has any issue, all he's got to do is call us. We can jump in here to the machine file through a computer anywhere in the world and tap into this and edit it, change it, and get them tied in. So, but I'm going to say we are good, and he just needs to add a little bit more material in here. See, now why can't Komatsu put a handle right here? You have to climb all the way up on the machine and reach all the way up to the top. Alright, so all we need to do is put this cover back on, and we are good to go. And just check that sensor, see if it was under warranty. Which it probably was, maybe. Was or was not, I don't know. We'll find out. So we'll just throw that cover back on and that'll be it. And that sensor is still in warranty. So, and it's in warranty until May 2022. So they get that for free. And the calibration and measurement and all that is just a complimentary thing we do. Of course, you got to do a calibration whenever you change a sensor, and it makes it so much better for the customer to be able to come out here and know that his machine is going to be cutting well. The thing that I often wonder is why we don't have an hours attached to calibration and measurements. And what I mean by that is, well, you know, you have your oil changed and hydraulic fluid changed at certain hourly intervals. Well, with blade wear and shim wear and pivot wear and all that stuff, calibrations do not stay good forever. As you just learned, the measurements change depending on what you're digging. Oh, these magnets are fun to get off. So it's best to have your machine calibrated before you hit a new job. And if you're going to be on a job for an extended amount of time, I would say once a month would be good. Because, you know, like this territory, I mean, look at how rocky this is. They've got some boulders, and you know that is digging away at that cutting edge and all these shims and everything else. So, yep, keep your machine calibrated. It's that simple. Thanks for watching. See you on the next.